Okay, so we've got ways to calculate limits. And what was the first way that we used to calculate a limit? Yes, sir. Using a table. Good. So we did that the first day. That was 2.1a. And then in one lecture, I threw 3 more methods in. That's why last night's homework was tougher, because it was 3 methods instead of just 1. So what was one of those methods? Yes, is it Austin?
Limit laws.
Good. So limit laws, which if you thought tables were a pain to write 2.9, 2.99, limit laws are even more of a pain to keep writing LIM, X arrow, da 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 da. And the reason I made you do that is just because it's easy. You need to know what the limit laws mean. We're not going to calculate many limits using limit laws, but the laws get used a lot. Okay, what's another way we calculated limits? Yeah, Zach? Okay, so we had this specialized where we figured out that the limit as x went to 0, sine over x was 1. And sometimes that limit could be isolated algebraically inside of a problem. And then you could just write down, hey, this is 1. I know it because it's a fact. And then the last one was the most fun one. That was called the Squeeze Theorem. That's the one when I talked about you on the highway getting smashed by 2 semis. That's what happens here. Okay, so that's what we've got so far. 4 methods for calculating limits. So we're going to add some methods today. So here's example 1. And the problem is the limit as x approaches 2 of x squared plus 5x minus 14 all over x minus 2. Okay, so we could try limit laws on this one, right? We could put the limit on the top and then the limit on the bottom separately. And then on the bottom, we could put the limit past the minus. So it would say limit of x minus limit of 2, right? So I don't want to write too much of that down because it's not going to work. But, and then the limit would be on the top as well, right? Okay, so what is this limit? Because the table is 1.92, 1.992, right? So those are getting close to 2. Is everybody clear on why this limit is 2? Okay, and then this limit is also 2. The table's slightly different, right? This is the function y equals x. So 1.9 spits out 1.9. And 1.99 spits out 1.99. So those are getting close to 2. Is everybody okay with that? Okay, so down here it's 2 minus 2, right? Which is 0. Which means the limit doesn't exist, right? It unfortunately doesn't mean that the limit doesn't exist. It means that limit laws didn't work. Okay, so I'm emphasizing that because at some point you'll probably forget that, and you'll get 0 on the bottom, and you'll say, oh, yeah, it doesn't exist, because it seems like that's what it should be. But what that means is, it means you don't know anything. Okay, so we tried limit laws here, but they didn't work, so we know nothing. So we need another method. And there's not any signs in the problem, so I don't think that's going to happen. Really don't want to use this. That's a pain in the butt. So I need a new method, and the new method is factoring. So what we're going to do on this problem is we're going to factor the top. So you put an x there, right? Because x times x is x squared. And then we're looking for 2 numbers that multiply to be negative 14 and add to be 5. So that's positive 7 and negative 2. Is everybody okay with that? Then x minus 2 is on the bottom still. Okay, and then that's good news, right? Because then the x minus 2's cancel. But I'm going to get a little more philosophical than sometimes. Why does x minus 2 over x minus 2 cancel? Yeah, Steven? Because if you take a number divided by itself, it equals 1, right? If you take 7 divided by 7, that's 1. So if you take x minus 2 divided by x minus 2, that equals 1. And multiplying by 1 doesn't do anything, so that's why we can get rid of it. Okay, here's a deeper philosophical question. Is x minus 2 divided by x minus 2 always 1? For example, if x is 7, it's 5 divided by 5, right? So it is 1. Is it always 1? I'm hinting that the answer is no. Why isn't it always 1? Yes. When x equals 2, it is undefined, right? So why can I just always pretend it's 1? Because over here, x is not 2. Because that's what x arrow 2 means, right? It specifically tells you to pick stuff close to 2 and not to make x 2. So we can really comfortably cross that out. Now you would have done that anyway because you're trained to cross things out whenever you can. And when you first did it in Algebra 2, off to the side, you'd say, well, if x doesn't equal 2. But after a while, we said, oh, everybody knows that. We're not going to write it down. But since then, you've kind of forgot to think about that. So anyway, okay, so now the x minus 2's cancel. So we have the limit, as x goes to 2, of x plus 7. Now we can use limit laws, because the limit will go past the plus. So that's the limit of x plus the limit of 7. So we tried limit laws initially, and they failed because the bottom came out to 0. So we factored, and now limit laws can work. So what's this limit? The limit of x approaches 2 of x. It's 2, good. And the limit as x goes to 2 of 7 is 7. Is everybody okay with both of those limits? Picturing a table in your head? Okay, so the final answer then is 9. So that means this limit is 9. So sometimes you've got a limit where limit laws are not working and you can factor and it makes the problem better. Okay, let's try this one. Yep. So could I do limit laws here? Why not, Lauren? You're right. So she's saying, hey, the bottom's going to come out to 0 if you try limit laws. So we could try that, but it doesn't work. Good, thank you. So we need another method. What about this? Any signs in the problem? So no. Limit laws, we already tried that. Table, I guess we could make a table, but it'd be a pain to plug a bunch of numbers into that. And we're trying to get away from tables. Squeeze theorem, is it factor? Okay, so we need another method. I call this one clear the double fractions. So you don't like fractions, right? This is even worse. It's a fraction that has fractions in it. So double fraction. If you, I think I made up that term. I think it's actually called a complex fraction. But anyway, it's a mess. So what we'd like to do is we'd like to eliminate it so that there's not a fraction of fractions. We'd like to make it so that it's just a fraction. Okay, so what you do is you look at the second denominators. So the only second denominator is x plus 1. What I mean by that is there could be a different problem that had an x down here and a 3 down here. And then the second denominators would be 3 and x plus 1. So you look at all the second denominators, which in this problem is just x plus 1, and you find the least common denominator of all those second fractions. So LCD of second denominators. So on this problem, that's easy because there's only one second denominator, x plus 1. So the least common denominator of that is x plus 1. So then you take that and you multiply it on the top and the bottom. So x plus 1 is the least common denominator, and we're multiplying that on both top and bottom. Okay, so it distributes past the minus. So we're taking x plus 1 times that first fraction, and that just gives you 3. And then if you take x plus 1 times 1, that's x plus 1. And then on the bottom, don't multiply it out. Just leave it as x minus 2 times x plus 1. Everybody sure they're okay with this? This algebra is, my opinion is that the hardest thing in calculus is all the algebra. But I just kind of assume you know. So is everybody okay with this? All right. And you are allowed to ask questions, even if you, especially if you feel like everybody else knows. Because if you don't know, there's definitely one or two other people that aren't sure. They just don't want to admit it in front of everybody. So if you admit it in front of everybody, I'll be impressed. Say, man, there's a brave soul. Even though I'm staring you straight in the face with my ugly face, still asked a question. So I'll be impressed. All right, so at this stage, then, I'm going to distribute the minus. 3 minus x minus 1. And then 3 minus 1 is 2. So we got the limit as x goes to 2 of 2 minus x all over x minus 2, x plus 1. Then you can factor a -1 out of the top. So -1 times -2 plus x. That seemed like kind of a weird step. Why did I pull the -1 out? Yes, sir. What's your name?
Michael.
Thank you, Michael.
-2 plus x times
Yeah, the -2 plus x, if you swap it, it's x plus -2, which is the same as x minus 2. So now these cancel. So I've got -1 over x plus 1. So I went through all that algebra to rewrite this nasty mess that I started with as that instead. And there's two advantages. First of all, this is a lot simpler, right? And second of all, limit laws work on this, because the bottom's not going to come out to 0 anymore when I take my limit. So I'm kind of doing a bunch of algebra to get it to a stage where the limit laws will work. So now I'm going to distribute the limit. I'm just going to do it in my head, though, because I don't want to write LIM down 3 times. So limit of -1 is what? Good. Limit of 1 is 1. Limit of x is 2. So then the final answer is -1/3. Yes, ma'am.
Why in that step the minus x plus the y equation also is
Good. So see where she is? She's right here. It's tempting to see that x plus 1 and that x plus 1 and cross them out. See why she's tempted to do that? So the reason why is because the top is a subtraction problem, and subtraction and multiplication don't mix together very well. If this was times, then yes, you could definitely cross those out. But with plus or minus, that messes that up. It's not quite as nice. Thank you, Ashley, because I'm sure someone else was tempted to do that. Because you just see stuff and you start canceling, right? You're like, oh, good, it's much simpler. I'm impressed, Ashley. You're the first brave soul to raise your hand and ask me a question. So. Yes, sir.
So then if the limit is 2 and it's never going to get to 2, why would you assume to plug in 2 at the x? You know, like, why would you ever...
You mean here?
No, in the first step, you would never have to divide by 0.
Right, but I tried limit laws in my head. So I wrote all those things down, on the top 2, and I made a table for this, and 1.9 was spitting out 1.9, and 1.99 was spitting out 1.99, and so this limit was going to 2. I didn't plug 2 in there. I did the limit, and I got 2, which is a very subtle difference. Because if I'm going fast, it seems like I'm just turning this into a 2, right? And plugging it in, but I didn't. So philosophically, I'm making a table in my head and seeing that it's getting close to 2, which means the bottom is getting close to 0, which means the limit laws are not working. So you're right, it's never actually 2, and so it never is actually 0. But limit doesn't ask the question, what is it actually? It's asking what it's getting close to. And it is getting close to 0. which means the limit laws are out? Fabulous question. Thank you. So now that's 2 people I'm impressed with. Later today in 8th period, you can impress me and come and ask some questions on homework. See, you guys are confused now. You're like, wait a minute, I thought it was bad if I had questions. I thought I was supposed to understand everything. It's actually not true. If we can figure out the small little subtleties of what you don't understand, then we can really go far. Everybody good? All right. All right, so we got just one more method to learn. This is in example 3. Okay, here this is the limit as x approaches 4. Okay, so I kind of already told you that we had a new method on this one, so I'm not going to pretend to think about these. But that's what you want to do when you see a problem, because you don't know which method you're going to use, right? So you just kind of go down through the list and see, hey, will this one work? Will this one work? But on this one, we need a new one, and it's called rationalizing. And that's going to happen when, not always, but a good potential time to use it is when there's a square root in the problem. So that's why this problem is a candidate for rationalizing, because it's got a square root in it. Okay, so you've been taught that it's bad to have a square root in the denominator. They just said, hey, don't leave your final answer with a square root in the denominator. And you still want to do that sometimes, especially on multiple choice questions. They might have rationalized. But on this problem, there's not a square root in the denominator. So at first glance, by what you've been taught, it's just fine. But there is a square root in the numerator. And if we did limit laws, the bottom would come out to 0. So we need to do something besides limit laws. So what we're going to do is we're going to rationalize the numerator. That's kind of weird. So we're going to multiply by the conjugate. So what I mean by the conjugate is, it's the same as this top, except I just changed this minus to a plus. So then I'm going to multiply everything out, except not the bottom. I'm not going to multiply out the bottom. So let's leave that alone. So I'm taking the x minus 4 and multiplying it by that whole big mess. And I'm not going to actually FOIL that part of it out, just leaving the bottom alone. But I am going to FOIL out the top part. Okay, so here's the firsts. Square root of x plus 5 times square root of x plus 5. What does that come out to? X plus 5, right? Because the square roots cancel. Just because you feel like everybody knows that, maybe you don't. Is everybody okay? All right, then this is plus 3 times that radical, right? And this is minus 3 times that radical. Those are going to go away, right? I can write it down, but I'd rather save my ink. Is everybody okay? plus 3 of those minus 3 of those. Just crosses out. Good? And then minus 9, right? Okay, then x plus 5 minus 9 comes out to x minus 4, which is good news because then that crosses out with this. So what's left on top? Good, 1. Remember earlier in the bell we talked about how that divided by that equaled 1? Okay, good. So we've got 1 over the square root of x plus 5 plus 3. And we're taking the limit as x goes to 4. So again, we just did some algebra. Because in the original problem, limit laws weren't going to work. So we did some algebra. This time we rationalized. And we got it down to a place where we can use the limit laws. So I could put the limit on the top with the 1 and the limit on the bottom, right? Then I can put the limit past plus. So there'd be a limit in front of this radical and a limit in front of that 3. The square root is a little bit tricky. What's another way to write a square root? 1/2 power, right? Can limits go inside powers? Yes, it was the last one that on the tape I forgot to mention. I got into the problem and then I added it, remember? So limits can go inside powers, which means they can go inside the 1/2 power, which means they can go inside this square root. Okay, so now we've got a limit in front of this 1, a limit in front of this 3, and a limit inside this square root. But then inside the square root, the limit can go with the x and the 5. So last night you had a couple of problems where you had to do just limit laws, right? And I wanted you to write down the LIM every time when it's a problem like that. But if you do a bunch of other stuff and you get to here, I don't want you to, you can if you want, but you can just skip steps and write think lim in your head, okay? As long as you don't think you're plugging the number in when you do that, right? Good. Okay, so what's the limit of 1? Okay. What's the limit of x? It looks like I'm plugging a 4 in for that x, right? But I'm not doing that. I'm making a table, 3.9, 3.9, 3.99, 3.99. Getting close to 4. The answer's 4. Plus 5, right? Plus 3. Then 5 plus 4 is 9. Square root of 9 is 3. 3 plus 3 is 6. So I got 1/6 for my final answer. Yes, Michael it was?
Yes. So if we take the square root of 9, how there's a positive and negative, do we ever have to incorporate that?
This symbol here actually is only the positive square root. Now, we have a misconception in our brain often because when we solve this equation, we kind of lazily write that on both sides. But really what we're doing is we're doing this on both sides.
So it starts out with a square root.
If someone has written down the symbol square root, that symbol means the positive square root. And then if you write down the symbol square root, you might mean the positive negative, but technically you're not correct. But it doesn't matter because then you remember to write this and we count it right anyway. Yeah. Okay, so that's good. We're pretty much done with our list of ways to calculate limits. And now I just want to practice a couple more problems since we have some time left. The first one I want to look at is this. Okay, so I'm just giving you some information to start out. I'm saying that the limit as x approaches b of this function is 7. So I'm just telling you the answer. The answer to this problem is 7. And then over here I'm telling you the answer to a different problem. It's -3. So this is information we're going to use in the problem. Okay, so now here's the problem I want you to calculate. I want you to calculate find the limit as x approaches b of 4g squared x. Okay, so first of all, what symbol could go in here? A multiplication sign, right? Can limit go past multiplication? Yes, that was the second limit law we had. So I can put limit of 4 times limit of this. So I'm going to write that down. So all I did there was use a limit law. Move the limit past times. Okay, then this g squared might be some notation you haven't seen before. What this means is it means the function g of x squared. So it means figure out what g of x is and then square your answer. It's kind of like sine squared, right? Sine squared means that. You've seen that before, but maybe not with a g or an f. Okay, so what's happening first here? Is the squaring happening first, or is the limiting happening first? I heard a couple mumbles. I wasn't sure what you said. He's saying limiting. Do you agree? It's actually the squaring that's happening first. So g of x is being squared, and then you take the limit of it. Okay, but there's a limit law that says you can switch that order, right? And do the limit first, and then square later. So that's what I'm going to write here. So up here it's squaring first and then limiting. And then I change the order. And here I'm limiting first and then square. And I'm allowed to do that because limits can go past powers. Just like with this square root over here, right? I'll put the limit past the half power. Now I got this other part, right? Yes. Do you mean did I have to write it down? I mean, the purpose of this problem is to practice the limit laws. So I guess I do want to see that practice on this, if there was a problem exactly like this, which there probably won't be, but yeah. I guess this is going to be a question that's going to be between everybody and me this whole year, like what do I have to write down and what do I not have to write down? I want you to write down enough so that I can tell you know exactly what's going on. But as time goes on, we can eliminate that to some extent. So there's not a hard and fast answer to that question. Yes, Michael?
Can you define the limit of g of x squared without removing the squared out?
No, because I don't know what the function g of x is. And so how would you know what that function squared was?
Isn't it top of 3?
G of x is not negative 3.
So it's okay.
The limit of g of x is negative 3. Good. Yeah, because this is new notation to you, and so your brain reads that first, kind of. Good. See what he was doing? So probably a lot of other people were doing that too. That's why questions are such a big deal. So please, thank you for asking that, Michael. Okay, so what is this limit? Good. Is everybody okay with that? And then this limit is negative 3. And then that's 9. So final answer is 36. Everybody still okay? Okay, so that was just the limit law problem with some notation that you weren't super familiar with. I think we've done enough to... Did the piecewise limit go okay on the homework? You know, the piece by piecewise, I mean, you got this, like, one function then another function. Did you feel okay about that? Yes?
Can you explain how we do that part? I didn't.
Yeah, well, the way a piecewise function works is it's one function, even though it's got two formulas. So that's confusing. And it tells you, hey, if what you're inputting is bigger than 3, you use this formula. But if what you're inputting is less than or equal to 3, you use this formula. So when you make your table, depending on what number you're plugging in, you might use different formulas. Is that enough?
No, I think I've learned it before. It's different.
Yes, exactly. And it kind of comes up out of thin air. And that's one of the things that's a little bit tough about this class is I kind of assume you know stuff from the past. And that's why questions like this are so important, because maybe it's like in the back of your head foggy, but so, and if you need to fix that problem later today, you can stop by now that you know how to do it. And sound good? Any other questions? Okay, so tomorrow's Friday. And what that means is, I think